Hi, okay, and welcome to this lecture on exception handling statements. In this lecture, we're going to learn about what exception handling statements are, how to use them, and the common errors that you might fall into with these. Okay, within our Maya window, let's open up the script editor. In your viewport, press and hold the spacebar. Okay, go to panels, panel, and the fifth one up, script editor. We can clear out our output window. We can also get rid of our channel box by clicking on the little icon highlighted in the top right. Okay, and what we're also going to do is go to the history drop-down and make sure that line numbers in errors and show stack trace is ticked on, okay, especially for this tutorial. Okay, what are exception handling statements? Well, they are a way for us to handle errors or exceptions that can occur in our programs. Exceptions are events that occur during the execution of a program that disrupt the normal flow of the program. Exception handling statements allow you to gracefully handle these exceptions, preventing the program from crashing or producing unexpected results. So, the try except statement is the most commonly used exception handling statement in Python, and it works by trying to execute a block of code, and if an exception is raised, it catches the exception and executes a different block of code to handle the exception or instead of the exception. So, the basic syntax for a try except statement is as follows. All right, let's give ourselves an error first. Okay, so let's go print foo. Oh, no, okay, we got an error. Okay, well, that's convenient. Okay, name error. Foo is not defined. Okay, we've essentially got a variable which is undefined. Okay, so what we can do is go for try. Okay, indent, go except. Okay, and then pass. All right, so what we've got here is, okay, we've got the code that may essentially raise an exception. We've put in here, let's say you've encountered random exceptions before, random errors before that you can't quite get your finger on, but you just need a program to run, okay? Not saying you should do this a lot of the time, but let's say you're against a deadline and you know it's working every other time and it's and your program is fine, okay? Put it here, figure it out later, okay? That's fine. But, okay, go back and fix it later. That's always fine. And then we've got the except, okay? This except does take exception types, but, okay, we'll talk about that a little bit later. Okay, and then we've got the code to pass, okay, if we raise an exception. Code to handle the exception essentially can go here. All right, so we can put, for example, print. Okay, we have an error. And look, now, instead of us getting our error that we received earlier, of foo is not defined, okay, we've caught that error. And we have said we have an error. So now you can still print hello world. Let's say this was our goal, okay, from this whole script. Okay, if we just have print foo and well, we're never going to print hello world because our code is failing here, okay? So what we need to do is make sure that we use our try, okay, and our except, and then we can quite simply say, well, we have an error, but we're still able to execute the rest of our code, okay? We haven't stopped our code running. So let's look a little bit more deeply into how we use, okay, these try and except functionalities, these exception handling, okay, cases. Let's have a look at some. So, all right, we have printed foo, we have printed out, we have an error. But specifically, we have a name error. And we may not want to just catch every error. Essentially, anything that happens here within this block of code right now is going to be caught. But what we are actually creating, if we look back up, is a name error. So what we're able to do is actually use that here and say, okay, well, if we get a name error, okay, then please print we have an error. Okay, and so there we go. We've got it. Okay, we've executed our code, highlighting it again, pressing Control and Enter. We've hit our name error, okay, and then we've printed out that we have an error. So we can use the name error specifically to catch just this type of error. So unassigned variables. But okay, let's say we use a value error. So this might be an error, okay, that we get when we're using some integers. Now, if we do this, we'll get a name error still, because we're now only specifically checking for a value error. So we're not going to catch this error, okay? But what you can do, let's say you've got two specific errors that you're expecting, and just go name error, okay, and value error, and then you are catching two types of error, which you are then going to go, we have an error, which I would then say probably best to go, we have a name error, maybe print out your variable. Okay, print out the information. So your logs, okay, so somebody can see this information. Okay, but one powerful thing we can always also do is have multiple, we can catch things with multiple different blocks of code to occur at different times. So let's say we have a value error. Okay. And we have a name error here. Okay, right now we're able to catch these different errors and do what we need to individually for these different items. So we've specifically stated we have a name error and we've executed this part of the code. This is incredibly powerful, and I think it's one of the nicest things about Python. I think this is a very easily and nicely laid out set of exception handling. Some programming languages aren't as easy as this, so this is one of the good things about Python. It's very nice and readable. So we can also maybe add some edge cases. So let's say you've got specific errors you want to catch, okay, within specific parameters, so a name error, value error. But let's say you're not sure about any other errors that you're coming through, but you've got to, again, have this run. Well, you can put an edge case. You can just go, another error has occurred. Okay, this way, okay, you'll catch a name error, you'll catch a value error, but you will, if there is a different type of error you've not foreseen, you will go, okay, another error has occurred. Okay. Let's also let the user know when maybe nothing went wrong with the function. Okay, so we can actually go, we can actually put an else in as well. So you've got if-else statements, but you've actually got try and else statements. So these can be used in for loops. These can be used all over the place. I suggest jumping into them a little bit because they're very useful for just, again, giving the user feedback. So we can go, no error has occurred. Okay, now this might be really useful. So let's change this from being food to print 1, 2, 3. So, okay, we've printed 1, 2, 3 because we were able to do this. Okay, we've tried, it succeeded. So we've printed 1, 2, 3. And then at the end of this this try except, okay, exception handling statement, we have then gone, no error has occurred. So we're actually giving the user feedback to let them know maybe within this specific block of code, no error has occurred. So again, another useful, really useful bit of functionality included in with Python. But okay, let's say we want to actually give the user feedback. Okay, let's say we're kind of expecting an error, but you know, we want to actually inform the user this time. Okay, we don't want to just kind of let it pass silently or let it pass, okay, within our function. Okay, let's say we've got a UI and the user has to copy maybe a controller shape to another controller. Well, what we can do is we can say, well, actually this won't be that specific example, but we can go maybe sheep count, okay, is higher than 100. Okay, then raise value error. Just, sorry, poor grammar, there's no excuse. Just typing terribly. Too many sheep for me to rustle. Okay, never rustled sheep, but feels like it would be a very comfortable crime. Actually, no, those things buck, don't they? I've been to farms. They are not gentle creatures. Okay, so anyway, what I was talking about earlier. So let's say, okay, within the scene, we have a controller that the user can select, and then select multiple controllers after that to copy the shape to. Okay, and then they're on the UI, they click a button which allows them to do that. Let's say they've only selected one control. Okay, let's say the item they've selected first, the driver, doesn't have a shape. Well, what we want to do is we want to check for these things. We want to say, well, only one item selected. So we're going to raise an error and say, I'm sorry, you've not selected enough items. Okay, a value error. If they have selected an item without a shape, okay. Raise a type error, okay. Type error, there is no shape associated with this DAG object, okay. So again, we just want to give feedback back to our users. So let's say control count instead. So we've got the controls from them. Whoa, we got a value error. Okay, and this is what will happen. It'll raise a value. You'll see it down here. Okay, it flashes red for you, so it tells you that something's happening. Okay, I probably won't use the exclamation mark when talking to your users. Might piss them off, okay, especially if they've had a stressful day. I'm all about the psychology of programming more than maybe you joking around and saying, you idiot, why didn't you select more controllers? Thinking it's funny at the time, but you might not be thinking that, I mean, I've done them 12, 14-hour day has just occurred for some poor developer or some poor TD on a pipeline that's using your tools and you're calling them an idiot. They might not take that too kindly. So just remember, try to always be kind and considerate with your programming, okay? Just say there's not enough controllers. Please make sure, or say that you select more than one controller. Okay, easy. Now, we've got over a bit too many lines here, so let's jump back. I'll add another couple here, and then what we can do, just jot that down. So here we go. Okay, there's not enough controllers selected. Please make sure that you select more than one controller. So this again, now we've got really useful feedback, okay, for our user, okay, and it tells them exactly what they need to do. Okay, so brilliant. Okay, let's look at this section of code which I've written out here as a good example. All right, let's, oh, sorry, actually, let's go back to our error we had earlier. Okay, all right, I forgot to actually, I've just realized I forgot to talk about, okay, finally. Now, you've got else, but you also have finally. Okay, this block is essentially always executed, regardless of whether an exception was raised or not. It typically is used to release the resources that were required in the try block, okay, such as closing files or releasing locks, or even logging the event for future debugging or auditing, okay. So else is only run, okay, if okay, nothing has gone wrong, okay, if you've gone through the try. So let's say, okay, so with foo, okay, let's have a little look. Let's do print. Finally, I have been called. So let's say we're printing foo here. Okay, let's give ourselves a bit more space. Let's clear our output window. Okay, and we're going to print. Okay, a name error has occurred. Finally, I've been called. So you'll see down here we've got nothing has gone wrong. Okay, this only works if everything works. Okay, but okay, this hasn't now been called because the finally has been called. So what has happened is we have printed out a name error. My God, sorry, poor grammar again. A name error has occurred. Okay, so we have executed this. Let's say you were opening a file up, you were trying to write to that file, okay, and an error has occurred, okay, a file error has occurred, okay, an IO error. But now what you want to do is you want to close that file, you want to make sure that everything is put back to how it was. This was how you'd do that. You would use the finally, okay? So, yeah, this is, I think, pretty comprehensive, okay? Well, obviously, you don't need this much depth fully if you're just expecting the except. But if you are always running into file errors, or maybe issues with writing to databases, this can be really useful because it gives you a way of closing that database, or being able to catch the issues that might occur with that database, either in or outside of the error handling statement. So let's have a little look. One more example that I've got. Yeah, here we go. All right, let's have a look here. So let's clean our code up. Okay, we've got a try, an except, an else, and a finally. Okay, so we've got some code that might raise an exception. As we've spoken about before, we're going to divide something by 0, which gives us, okay, a 0 division error. Okay, it's a class and it's a type. Okay, so let's try running this, see what happens. Okay, well, error. We're printing, okay, division by 0. So you can't do this, okay? And what has happened at the end? We printed finally done. But let's say this was user input. So let's say this was user input. And somebody put 0, which has caused the error. Let's say the next time they put 1. Okay, the result is 10. Okay, so if the code is successful, okay, we can print out the result. Okay, but if it's not, then we can do something else. Okay, so there's another example for you. But again, such powerful things. I love the exception handling. Again, I wouldn't say you're going to have to use this too much specifically within Maya functionality. Generally, you should be able to write code that isn't failing and you shouldn't have to catch the fails. Okay, and maybe on the fly, like I said, if you're up against a deadline and you just need something to run, then fine. If it's able to run while you're catching an error, which you're unsure of why it's happening, go back and fix it after. But generally, these are used with, app creation, something that is calling a database, something that has multiple calls to one file, and that will catch certain specific cases for you in there. But, okay, let's see, what else have I got on my notes? Okay, so in this example, the try block contains the code that might raise a 0 division error, okay? If this happens, the control is transferred to the except block, which prints an error message. Right here, okay. So finally, the finally block is executed, which prints done, okay, to indicate the program has finished, okay? So these checks are very useful, just remember all of that, okay? So, okay, let's have a look. So these checks can be useful in programs for users to let them know when they've made an error, okay, especially with our raising an error where we raise the error ourselves, okay? These let the users know that they have made an error and they stop the error being passed further down or upstream, okay, to our scripts, okay, where we will then raise an error because they haven't corrected the functionality. So it's a good thing to catch with raising an error for the users so that they know they've made an error and we won't then have to fix it downstream. Okay, especially if you're telling them, like we did, how to fix it. Okay, let's have a look at some common errors. Let's clear our window at the top. Let's have a look. Okay, let's copy all of these in. I think I had a bit of a field day with these. I thought of quite a few. So, catching too broad an exception. Okay. Now, like we did earlier, you can just do try except without having the name error or the type of error that you're catching, but it's a bit too broad. And catching all such exceptions is a little bit dangerous, okay? Because you might have multiple errors happening within your code, but you won't know what they are, and you won't know what the further implications of that is further down your script. Raising exceptions incorrectly. If you raise an exception incorrectly, you might end up making the actual error that occurred, or you might mask the actual error that occurred. So, like I've said, okay, if you actually mask the error that has occurred, you're actually going to be, again, pushing that downstream and then not catching a different error, but creating another error, essentially, within your code. So, you're indenting a block without logging or without re-raising the original exception, and it can make it harder to find the root cause because then if you look back at the exception or the line error where it's occurred, you're going, well, oh, I thought I was catching this error. Oh, it must be something else. But obviously you've got a logical error. You've actually written the code wrong yourself. Sorry for jumping over my words there. That might have confused you a bit. But okay, let's have a look at improper use of the try, except, else, and finally. Now, yeah, definitely take notes on this like we've seen. look at further resources on maybe W3 schools. Again, they do really good breakdowns of this kind of thing. But okay, so when using the try, except, else, and finally statements, it's important to place them in the correct order. If you put the else block before the except block, for example, you'll end up with a syntax error. Okay, this is simple and it will give you the errors, but yeah, just make sure they're in the right order. Okay, because it'll also help your thinking. And still comment them if you're unsure. If you're new to them, you can always still comment exactly what they're doing at each step, just to remind yourself. Not using the correct exception type. Again, easy to do, or even just leaving it empty. But this is really useful for you when raising an exception. If you raise a type error when you should have raised a value error, for example, it can be difficult to understand the error that has caused it. Okay, so for example, if we're telling the user that we have a type error that when they're selecting controls, let's say we go back to our analogy of copying controllers shapes over to other controllers. Let's say that you've told them that they've got a type error when they've not selected enough controllers. Well, they've actually got a value error because they've selected the right, but the right type of object, but they've not selected the right number of them, not the right value. So correctly giving them the right error, whether it's a type or a value error, is quite important because it'll inform pupils' decision making going forward. And the way that you write that information and provide it to them can obviously save time on long days. Think about the worst case scenario. Okay, is that developer going to be always using your tool when they're bright and they've just started, they've got their coffee in hand, or are they going to be using tools at the end of long days on tight deadlines where they are going to be stressed out? Yep, it's going to be the latter some of the time. So make sure that you help those developers, you help other people using your tools, okay, by giving them great feedback. Not handling exceptions at the right level. So let me think about what this means. So if you catch an exception at a higher level than necessary, you might not be able to take the correct actions to recover the error. So conversely, if you catch an exception at a lower level than necessary, you might end up with unnecessary code duplication. So let's say you, let's try and use a real world example of that. Let's say you let your code all run, with the wrong objects being selected in the scene that don't have a shape, and we're trying to copy that controller shape over to multiple controllers. Okay, we are essentially going to catch that the controller is or the original driving control doesn't have a shape that we're going to copy over to the other items, but we're only going to catch that after we've tried to copy it over. Now, what you might end up doing here is deleting all the shapes from those other objects, and then not being able to copy them, because there are no shapes, and then catching that error after you run the functionality. Obviously, that is using it at a lower level downstream where it needs to be. So make sure that you put your error handling in the right place. Okay, all right. Thank you so much for listening to my babbling, and I'm hoping that it all made sense. I do love the exception handling essentially in Python. Hopefully you shouldn't be using it a huge amount, although you will be raising exceptions to, again, give users feedback a lot more. So I'd say you'll use that more than maybe the try catch or the exception handling try catches. So in this video, we have learned about exception handling statements, how to use them, and common errors. If you have any questions, please feel free to post them. But thank you so much for listening, and I look forward to seeing you in our next video about maps and filters.